Just draw a quick graph of both of these to see what they look like. F of x is a straight line with a y-intercept of 2 and a slope of 1. So there's my graph of f of x. G of x is my absolute value graph. That looks like that. Domain and range of each of them. So my domain of my line is everything. My range is everything. Domain of my absolute value graph is everything. Range is just where y is greater than or equal to 0. An explicit equation means that you're going to write h of x in terms of x only. That's what an explicit equation is. So right now, h of x is written as f of x plus g of x. If I wanted to write that as an explicit equation, instead of f of x, I'm going to write x plus 2. And instead of g of x, I'm going to write plus the absolute value of x. Now, as far as figuring out the domain and range, you could look at what we have here and decide that, all right, when I add these together, the domain was everything here, the domain was everything there. So my domain for this one will be everything as well. Or you could just look at your new explicit equation. Once you combine it together, are there any non-permissible values for x? No. So x will be everything. The range of this is going to be a little bit more difficult. Okay? What's going to happen when we add these two graphs together? Well, let's just look at a couple of points. For example, at 0, we have 0 on this graph, 2 on this graph. If I add those together, I'll be at 2. I've got 1, 3 and 1, 1. So on here, I would have the point 1, 4. Does that make sense? Because on my green graph, I have 1, 1. On my blue graph, I've got 1, 3. So if I added those together, add my y-coordinates, I get 1, 4. Can you see that this is going to go up like this over here? That you're going to keep adding those points there. So as far as my y values, they're going to keep getting bigger and bigger and bigger. But as I look on the left side, can you see that over here I'm going to go negative, but over here I'm getting bigger in a positive direction? So what's going to happen? Well, again, let's look at some points. Let's look here. At negative 2, I've got 0. And at negative 2, I've got 2. So if I add those together, I'm going to get 2. What's going to happen here? If I go up by 1 here, I'm going to go to 3. But over here, I'm going to go to negative 1. It's going to stay flat at 2 after that point. What's going to happen at 1? Here we have a value of 1. Here we have a value of 1. It's going to stay flat at 2 all the way through. So when we add those two graphs together, it's going to be flat at 2 all the way through here. So our range is y is bigger than or equal to 2. for some of our equations, we won't be able to figure out our range by hand. We're going to have to put it into our calculator and see what the graph looks like to figure out what our domain and range is. So for example, the next one says, given that these two are multiplied together, write an explicit equation. So for part C, my explicit equation for p of x, f of x is x plus 2 times by the absolute value of x. That's not a graph that you've ever seen before. So how would we see what this looks like if we wanted to look on our graphing calculator? Again, we would know just by looking at that equation, the domain is still everything. There are no non-permissible values in that equation. We're never dividing. We're never taking a square root. So our domain is everything. But when we want to look at what does this graph look like, if I go x plus 2 multiplied by the absolute value, know where the absolute value is, hit math, go over to number, and the very first one. So if we look at what this graph looks like, almost looks like an x cubed graph with a little bit of a bounce at x equals 0. And in this case, the range is everything as well. And we could see that from the graph. As far as seeing the range is everything from multiplying, one thing I'd like you to notice. Notice that our green graph is always positive. And that our blue graph, the y values are sometimes positive and sometimes negative. Can you see that? So wherever the blue graph is positive and the green graph is positive, a positive times a positive will be positive. And if you're multiplying these together, can you see that as you go and get bigger and bigger values of x, like x goes to 10 and then x goes to 20 and then x at 100, that you're going to be multiplying bigger and bigger numbers, that it's just going to get bigger and bigger and bigger. And when you go to your negative numbers, the green graph gets bigger positive numbers. Your blue graph goes to bigger negative numbers. And so when you multiply them together, you're going to get bigger and bigger negative numbers. So it makes sense that your range would go from negative infinity to infinity. Okay, the questions you can do after this one are 3, 5, and 10.